This is Check Your Understanding for 3.1.1b for simplifying fractions using the GCF, or the greatest common factor. We are working on medium problems. So let's start with 24 and 36. The first step that we want to do to simplify is to create factor trees for both of our numbers in our fraction. So we ask ourselves, what times what equals 24? And I like to start with 2 if it's an even number, just gives me half right away. And 2 times 12 is equal to 24. And I circle my prime factors so I know that that branch of the tree is done. Then I'll move on to 12. What times what equals 12? 3 times 4 equals 12. 3 is a prime number, so I'll circle that. And then I'm left with 4, which is 2 times 2. So there are my prime factors for 24. Moving on to 36. It's an even number, so I like to start with 2. And 2 times 18 is equal to 36. 2 is a prime factor, so I'm going to circle that. Then I'll move on to 18. And I ask myself, what times what is equal to 18? And I will go with 3 and 6. 3 is a prime factor, so I'm going to circle it. Then what times what is 6? 2 times 3 is 6, so I will circle both 2 and 3 since they are both prime factors. The next step is writing my fraction as the multiplication sentence of all of my prime factors. So 24 is 2 times 2 times 2 times 3. And then 36 is 2 times 2 times 3 times 3. So now I'm going to go through and look for my giant ones, because what I know is that any number divided by itself is equal to 1. And I can write a division problem as a fraction, 2 divided by 2, and that can still be equal to 1. So here we have a giant 1. We have another giant 1, which is 2 over 2. And then we have another giant 1 over here. So if your giant ones don't line up like mine, you can rewrite them so that they are 1 over each other. I kind of try to line them up when I am laying them out. Then our next step is taking all of our giant ones and multiplying them together to be one giant one. So in essence, we would have 2 times 2 times 3 as a giant 1, which would be equal to 4 times 3 is 12. So I'd have a giant 12 over 12, and then whatever I'm left over times 2 times 3. And this would be my simplified fraction. So I'm basically taking out the greatest common factor, which is 12, and what is left is my simplified version. So 24 over 36, the simplified version, is 2 thirds. All right, moving on to the next one. I'll draw my line. We have 30 and 48. So the first step is to do our factor trees of 30 and 48. 2 times 15 is 30. 2 is a prime number. 3 times 5 is 15, and both of those are prime numbers. Then we'll move on to 48. Since it's even, I'm going to start with 2. 2 times 24 is 48. 2 times 12 is 48. And the fun thing is I already have my tree up here, so I can double check as I'm going through that I have everything. 3 and 4. 3 is prime, and then 2 and 2. So now the next step is to rewrite each number as multiplication sentence of its prime factors. And I'm kind of looking to see what I need to line up here so I can make my ones. So I know I have a 2, a 3, and a 5 for my 30. And here I see a 2 and I see a 3. And then the rest of them I can just put in there. So that's one way you can get your ones to line up to be the giant one. Next, we're going to go look through our giant ones. We have a 2 over 2 and a 3 over 3, and then we are left with these. We'll create our put together giant one, which is 2 times 3 is 6 over 6. And then what we'll do when we have more than one, like up here we just had one number in each, what you do is you just multiply them together. So we just have 1 on top, which is 5. And then down here we would multiply these together. 2 times 2 is 4, times 2 is 8. And so this would be our leftover fraction in our simplified form. So 30/48 is simplified into 5/8. All right. And then finally, we have 18/45. The first step is to do our factor trees. Since it's even, I'm going to start with a 2 times 9 is equal to 18. And then 9 can be 3 times 3, which are both prime factors. Then we'll move over to 45. It is not even, but I know because it ends with a 5 that it can be divided into 5 times something, and 5 times 9 is 45. 5 is a prime factor, so I'll circle that. And then 9 is 3 times 3, which are both prime factors. Then we will rewrite our fraction as a multiplication sentence of each of the prime factors. So we have 2 times 3 times 3. And then looking over here to get my giant ones, I see that I have 3 3s. So I'll kind of put those under the ones that I already have. And then I'll put my 5 at the beginning. Then I'll create my giant ones. Then I'll rewrite my sentence as 2/5 times my giant 1 of 9, or my greatest common factor. And then my simplified version, 18/45 can be simplified into 2/5. The back side, we start with a dot pattern. And we just study the dot pattern below to answer the questions in the next row. We have spaces for 5 figures, but we're missing figure 3 and figure 5. In the mild section, we were to create figure 3 and figure 5, which are over here. And if we look, we are starting with 4 dots, and each figure we add in 2 dots. So figure 3 would be figure 2 plus 2 dots on top, and then figure 5 would be figure 4 with 2 dots on top. So what we need to do for the medium is figure out how many dots are going to be in the 50th figure. I'm going to fill in figure 3. And I'm going to fill in figure 5. And then I'm going to count how many dots in each one and just see how it's related. So we start with figure 1, we have 4 dots. Figure 2, we have 6. Figure 3, we have 8. Figure 4, we have 10. So we know that it is counting up by 2s. And figure 5, we have 12. So what I could do is, if I'm starting at 1 and I know I start at 4, I could just count by 2s up to my 50th figure. Or I could create an equation, which is actually in our spicy. So I know one way to figure out equations is going to figure 0. And I know if I'm adding 2 going up, I know that I'm going to be taking off 2 to go down. So I am starting with 2 dots. And then I am adding on 2 each time. So I add on 1 set of 2 here. If I start with 2, I'm adding on 2 sets of 2. This is my starting, so I'm adding on 3 sets of 2, or 3 times 2. Similarly, I'm starting with 2, and then I have 1, 2, 3, 4 sets of 2. So what that is figure number times 2, or 2n. So let's check it and see. So if I have figure number 2, that would be 2 times 2. And in figure number 2, is that how many we have? 6. We can try another one. Let's say figure 5. We would have 2 plus 2, figure number 5. That would give us 12. Or I mean 10, sorry. With a total of 12, which is here. So if we wanted to figure out how much was in the 50th figure, we would do, I'm running out of room, 2 plus 2 times 50, which would be 2 plus 100 for 102 dots. All right. If 2 notebooks cost $5.20, how much would 3 notebooks cost? So this is really asking us, we have $5.20 for 2 notebooks. But we really want to find out how much 3 notebooks would cost. One way to go about solving that would be to figure out how much for 1 notebook, which is called a unit rate. And we would do that by dividing 520 by 2. So I know $5 divided by 2 is $2.50 plus then 10 cents. So each notebook would cost $2.60. And I would take this now and multiply it by 3, because that's how many notebooks I want. $2.60 multiplied by 3. 3 times 0 is 0. 3 times 6 is 18. 3 times 2 is 6 plus 1 is 7. And since I have a decimal that goes 2 in here, I also need to have a decimal that goes in 2 in my answer. So 3 notebooks would cost $7.80. For the bottom portion, you need to have completed the previous problem to solve, which we figured out what the length around the soccer field would be, which is 390 yards. So if Stacy walks around the field 4 times each time she exercises. So we have to look at each day first, and then we have to think about each week. So it's a 2-step problem. So first, if each lap around the field is 390 yards, and she does that 4 times, and I'm actually going to write it vertically because it's easier to multiply. So 4 times 0 is 0. 4 times 9 is 36. 4 times 3 is 12. Plus 3 is 15. So we know each day that she walks is 1,560 yards. And then we want to look at for the week, which I'll put that over here just because it's easier. And then if we go back to our original problem, we know that Stacy exercises 3 days each week. So if she goes or she walks this much each day, we're going to take that number and multiply it by 3 because she walks 3 days a week. So we have 3 times 0 is 0. 3 times 6 is 18. 3 times 5 is 15 plus 1. 3 times 1 is 3 plus 4. So total each week is 4,680 yards.